Yeah, right. We're going to go through a couple of the examples from this worksheet. Number 12, find the equation of the circle with center at negative 4, 7 and passing through 5, 0, negative 4, 7 and passing through 5, 0. I'm going to call on Sketchpad, take a look at that. Okay, here's my point here at negative 4, 7, and here's my point on the circle at 5, 0. Okay, and so what that means then is that, okay, the distance from A to B, the distance from the center to a point on the circle, is otherwise known as the radius, right? So then when I go to find my equation of the circle, I have my center. All I need is my radius. So we come back and we take a look at our computation over here. Here's our form for the equation of a circle right here, okay? And x minus h quantity squared plus y minus k squared. hk is the center, negative 4, negative 7, so I put that down there, is equal to the radius squared. Again, as we showed here on the computation, the distance between that center and that point on the circle is in fact a radius. So I will simply use my distance formula. Distance formula as written here, distance equals square root of x1 minus x2, quantity squared, plus y1 minus y2, the quantity squared, with these points. So it's 5 minus a negative 4, 9 squared, plus 0 minus negative 7, plus 7 squared, so that's 81, and 49, which will give me, what, the square root of 130. So the square root of 130 is the radius, and since this calls for the radius squared, that's simply going to be equals 130. And here's the equation of my circle. Okay, let's take a look at this number 14. Find the equation of the circle circumscribing the right triangle with coordinates at negative 6, 3, negative 1, negative 2, and 2, 1. Okay? Again, I'm going to first just take a look at that through Sketchpad. Okay, so here's my points plotted. There's negative 6, 3. There's negative 1, negative 2, and there's 2, 1. And there is a triangle, of course, that contains those 3 points. And that is supposedly a right triangle. And I can see that it's a right triangle. In fact, I can validate that it's a right triangle right here and show that it's a right triangle. If I were checking this without the sketch, I would say that, well, it looks like the AB and BC are perpendicular, so I would check their slopes. The nice thing here is that, of course, once we know it's a right triangle, all we have to do is find the center of the right triangle, which is, of course, the midpoint of the hypotenuse. So here's my hypotenuse AC. Find its midpoint, okay, and then that midpoint is the center of the circle that circumscribes it. Okay, so there is my circle. There's my equation, and let's see what we have to do to illustrate that in terms of the algebra involved. Okay, so here we go. We said that AC is the diameter effectively. Go back, take a look. AC is the hypotenuse of the triangle. It's also the diameter of the circle. So in essence, it's really not any different than the problems that were asked earlier on this worksheet, which we had an earlier video on, something like number 9 and 10, the circle of the diameter endpoint. So here, essentially, we're saying, okay, AC, find the midpoint of AC. So midpoint of AC is going to be the center. Midpoint of AC is the center. And of course, what's the midpoint of AC? Well, that's negative 6 plus 2 over 2, comma, 3 plus 1 over 2. So that's negative 6 plus 2 is negative 4. and that's negative 4 over 2 is negative 2, and that's 4. Negative 2, 2 is the center. And then, okay, we could simply go and compute the distance between, let's call that point D, between D and A, okay, because that would be the radius. Or we could take the length AC and cut it in half. Or, as I said, we could take the distance from A to D. So we'll go with the distance formula between 6, 3 and this newly found point of negative 2, 2. And so that would be, the distance would be negative 6 minus a negative 2, the quantity squared, plus 3 minus 2, the quantity squared, and that would be negative 6 minus a negative 2 is plus 2. That makes that negative 4 squared. Okay, and that would be 1 squared, 1. So this looks like what? 16, the square root of 17, which is, okay, which is going to be my radius. So my circle should be of the form, what? X plus 2, the quantity squared, that's minus a negative 2, plus y minus 2, the quantity squared, is equal to 17. Okay, and that should be pretty much in agreement with what we had there. Okay, 4.12, I bet when squared would be 17. All right, and then lastly, just advise you on this, okay? Find the equation of the circle circumscribed about a rectangle with these coordinates. Well, if it's circumscribed about a rectangle, then basically, okay, the diagonal of the rectangle should be the diameter of the circle. So if you plotted these, number 16, the segment AC should be the diagonal of the rectangle as well as the diameter of the circle. So, of course, if it's the diameter of the circle, the center is on the diameter and the radius is half of that, okay? And you can do that. And I think there was a flaw with number 17. There was one of these points was miscalculated, so don't worry about number 17 for now, okay? Don't worry about number 17, but 16 and the rest of them you should do. Again, 16, remembering that you have, we could probably just show you that, okay? Because if I had, I'll tell you what I'm going to do real quickly just to illustrate this. I'm going to draw a perpendicular to this, and that would construct for me the rectangle. Okay, and so here's a rectangle. Let's go here again. Construct that intersection right there, and that point. Okay, that point now will form a rectangle, and you can clearly see that the rectangle there, all right, is that the diagonal of the rectangle, okay, the diagonal of the rectangle is in fact the diameter of the circle, all right? So the diagonal of the rectangle, whichever diagonal you pick, okay? So here's this diagonal. The diagonal of that rectangle is, okay, the diameter of the circle, and the midpoint of the diameter of the circle is the center of the circle. So you should be able to take care of those problems as well that are there for you, okay? All right, so that's it, and get them done.